Hi everyone! In this tutorial, I'll walk you through the simple steps of implementing Inter-VLAN routing in Cisco Packet Tracer using the router on a stick method. I have already prepared 3 networks that will assign to 3 VLANs. This will help us to easily determine what IP addresses to assign to the devices. Once you've opened your Packet Tracer application, the first step is to add 2 switches and 3 PCs for each switch. Connect the 2 switches using a copper crossover cable. Just like in my first tutorial, we'll use copper straight through cables to connect each PC to its respective switch. After setting up the hardware, let's move on to the command line interface of the first switch to start our configuration. We'll begin by creating VLANs 2, 3, and 4. Next, we'll assign each PC to a VLAN by entering the following commands for each fast Ethernet port connected to the PC. Now, for the port that connects switch 1 to switch 2, enter the switch port mode trunk command. So, why use switch port mode trunk? This command allows the port to carry traffic for multiple VLANs between the switches. Without it, the switches wouldn't be able to forward VLAN tagged packets to each other, which is essential for inter-VLAN communication. After configuring the first switch, exit the CLI and repeat the same VLAN and port assignments on switch 2. Next, go to the desktop, then IP configuration tab for each PC and assign an IP address, the subnet mask, and the default gateway that matches the VLAN it is assigned to. Here's the VLAN assignment for our PCs. PC0 and PC3 belongs to VLAN 2. PC1 and PC4 belongs to VLAN 3. PC2 and PC5 belongs to VLAN 4. Let's test basic connectivity. Try to ping PC3 from PC0 that belongs to the same VLAN. As we can see, the ping is successful. Now, try to ping PC1 from PC0, which is from a different VLAN. As we can see, the ping is not successful. Now, why did the inter-VLAN ping fail? Switches alone can't route traffic between VLANs. That's why we need a router specifically using the router on a stick method to enable communication across VLANs. To fix this, let's add a router. Connect it to the switch 1 using a copper straight-through cable. And on the switch port that connects to the router, let's use the switch port mode trunk command. Now, go to the router CLI and configure sub-interfaces on the port connected to the switch. Now, let's configure the router for inter-VLAN communication. To do this, we'll use the router on a stick method, which involves creating sub-interfaces on the router's physical interface. Each sub-interface represents a different VLAN. For each VLAN, VLAN 2, VLAN 3, and VLAN 4 will create a sub-interface on the router, assign it to a specific VLAN ID, and provide it with an IP address that will serve as a default gateway for that VLAN. This setup allows the router to receive and forward traffic between VLANs, making communication possible between devices assigned to different VLANs. Finally, make sure to enable the router interface by entering the no shutdown command. Now, let's test connectivity again. First, let's try pinging between PCs in the same VLAN. The ping is successful. Now, let's try pinging between PCs in different VLANs. And as you can see, all of the pings are also successful. This confirms that our inter-VLAN routing is working properly using the router on a stick method. And that's it for today's tutorial. See you next time!